Protocols will never be the same with the latest Swift update? Don't choose KeyPath anymore. Meet the new MacBook Air and Swift for embedded systems. Stay tuned for this and other news for iOS and macOS development. I am Roman Mishchenko, an engineer in Clean My Mac team, and let's get started. We've recently told you about the launch of Twist 4. With this release, the project deprecated Twist Env as a version manager and transitioned to Mise. Written in Rust, Mise is a new version manager tool that deserves your attention. It reminds me of PyEnv, NVM or SDF, but crucially, it's not limited to just one programming language. It can handle multiple versions of tools and automatically switch to the appropriate one when you navigate to a folder in your terminal. This magic happens thanks to a tools version file located within a directory. On top of that, Mise can manage environment variables, allowing you to specify configurations like access key ID, which may vary across projects. What version manager tool do you use? Share in the comments. Apple has released a new version of Swift, version 5 and 10. The updates focused on ensuring data race safety and also fixed numerous bugs in Sendable and Nectar, checking the strength and guarantee of complete concurrency. Apart from that, Swift now finally supports nested protocols. This means you can create protocols that are part of a struct, class, enum, actor, or even a function. It opens up a new exciting possibilities for us as developers. As a bonus, delegate names can now be much shorter, making structure of your code simpler. Along with the new Swift version, Apple also released the new Xcode 15.3, which comes with several interesting changes. Firstly, they improved Swift UI preview, making it less likely to fall and adding the ability to take screenshots of the previews. Secondly, Xcode will now alert you if any global or static variable needs to be either isolated from the global actor or made both immutable and type of sendable. Lastly, Apple updated the standard C++ library with new features and higher performance. Apple has also unveiled the new MacBook Air. This time, they decided to skip the big presentation and opted for a press release. The new Air features the latest M3 chip, but retains its previous design. It comes with an upgraded Wi-Fi 6E module. Voice isolation support has been added, which should enhance the clarity for audio and video calls, making Zoom calls even better. Interestingly, Apple also updated the SSD, which now consists of 2 NAND chips. This not only boosts the SSD speed, but also could improve swap memory performance when RAM is fully used. The base model continues to offer 8 GB of unified memory and 2056 GB of storage. Its starting price remains unchanged at $1099 for the 13-inch model and $1299 for the 15-inch model. Meanwhile, Apple has kept the Air with M2 processor on sale, but lowered its price by $100. However, Air models with N chip has been discounted, meaning all current MacBooks have now transferred to a new design with a notch. Swift still has a bunch of unresolved issues. Let me explain. At Swift forums, developers are discussing challenges creating back-end solutions on Linux using Swift. Interestingly, they pointed out the absence of dynamic libraries for Linux that supports library evolution, the lack of library archive as a type of artifact for SPM, and increased build times on Linux, and delays on Swift updates, like ability to use macros. There is also a familiar issue most developers face with SPM caches and derived data, when you might have to completely clear them, because Xcode can find a certain library. Maybe someday Apple will manage to solve this problem. Important detail: the article mentions the KeyPath performance issue in Swift. Actually, this problem isn't new, and benchmark found on GitHub from as far as back as 2018 shows that using KeyPath can significantly reduce code performance by many times over. We decided to test it ourselves and found performance drop from 5 to 10 times compared to direct access. This is much better than it was 5 years ago, but there's still need for improvement, so be careful when using KeyPath in your code. A new article appeared on the Swift org. Developer shared his experience coding for Playdate. Playdate is a small handheld gaming system created by Panic. It's equipped with a Cortex M7 processor and 1-bit display with 400 by 240 pixels and has a small runtime for hosting games. Because of this, most Playdate games are written in C and Lua. But how does it relate to Swift org? The thing is, for some time now, Swift has been developing a new embedded language mod to support embedded platforms. This mod uses additional language restrictions to create tiny binaries, while still retaining the core features of the language. The author of the article ported a test project to Swift and found that the game's binary file in Swift was 13% smaller than in C. That's 116 bytes less. It's important to note that neither version of the project was optimized, but Swift results are still impressive. The author also described in detail the development path from simulator to actual device. For now, all work is available for download, so you can also try a Swift in an unusual format. All links will be in the video description. This wraps my first episode. Hit that like button and don't forget to subscribe for more updates. See you next time.